Hello everyone, welcome to the first video of Genius Math Tutors, and today we're gonna do a tutorial or a lesson about multiplication for third graders. So we have two problems here. So in third grade you learn about about multiplication. That's one things you learn in math during third grade. And there's many others, but today we're going to focus on multiplication. Multiplication for third graders. So in third grade you learn multiplication factors, like for example 2 times 5, which is 10, or why is 2 times 5 is 10 is because it's like two groups of, maybe for example there's like two plates with five maybe apples each, so 5 plus 5, 10. Yeah, that's how multiplication works. So we're gonna take a look at these examples here. Okay, let's get started. So the first question, what's 5 times 3? Well, there's many ways to solve this, but I'll show you not all of them, which is sort of, I'll show you some of, like, the maybe like obvious ways. Not obvious, but like, yes, the ways I do it, or many others, like, how many people do it. So here, so first way is do an array, which is like this. So 5 dots. Yeah, that's 5. Oh, maybe I could do better than that, I guess. I'll undo that. Okay. I'll do that, do that, do that. And that's, oops, let me make that dense. Yeah, so that's 5. And now this is 5, and now we need 3. 1, 2, that's 3. And the important thing about the array is, for now, let's first finish this. Oops. Oops. Sorry, guys. Sort of. Still. Yeah, we could. Okay, so now I want to explain this here, over here, how this dot is very important. This applies for like this way, oops, this way, and this way. That's how the array works. So let me redo that. It's sort of like there. So we're gonna, this dot here has to go this way and this way. That's very important. Or if you do it like, for example, just do it like this and just do 2, that's incorrect already. If you do it like that, 5, it's like, that's now like how you necessarily do it. But still, so why you have to do it like this is because if you do just, so this circle proves that this dot counts as like this line, and this dot also, this dot plot, or dot also counts as this. Yeah, that's why it's important, these circles. So technically array is maybe Yeah, so let's count. To prove this is 5 times 3, what is the answer? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 5. Yeah, you go 5, 3, 3, 3. So there's technically 3 rows of 5 or 5 rows of 3. Yeah, that's how multiplication works. And the answer is technically 15. But let's do another way. So this is number 1. Let me do that. So the second idea is second way to solve this standard algorithm. Like 3 times 5. Actually, never. Let me do that again. I mean 5 times 3. That's more like it. Well, this sort, second, so, which is 15 too. Well, like, at first you won't really know why 5 times, like, using the standard algorithm, why 5 times 3 is 15. Then you could do these two together. Like, you could do the standard algorithm and this to get the array I told at first together. Then you could prove that 5 times 3 is 15. Okay, the third way I'm telling you is, well, maybe there's, maybe like 5 bowls like this. 1, 2, 3, 4, 5. And inside those bowls, there's 3 dots, maybe 3 cookies. Let's say these dots are cookies. Or you could say the 5 is cookies and the dots are chocolate chip. That's maybe a better visualization. Excuse me. Let me finish that. So, okay, one more. Okay, so there's 5 bowls or cookies, maybe the 5 cookies, and there's inside those are maybe 3 cookies or chocolate chip inside this cookie. So there's 2 ways. Any way is fine. So here now, so there's 5 bowls. So 1, 2, 3, 4, 5. So there's 5. So you call this maybe 5 groups of 3 groups, 5 groups of 3. Okay, let me just write that rather than actually. Okay, 5 groups of 3. So what this means here, I'm circling this, is that, oh sorry, my handwriting's not that good. Okay, so let me write that. Okay, that's better. So there's technically 5 groups. This one circle here, this one circle is a group. And technically of 3, of is very important. Of means multiply. And that's how, that means multiplication. Let me rewrite that 3. Yeah, so 5, there's 5 times yeah, there's 1, 2, 3, 4, 5, and inside those, you could count those chocolate chips. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This also equals, this equals, this whole thing here equals 15. And there's more evidence that 5 times 3 equals 15. Yeah. Okay, so next problem. 3 times 6 equals what? Well, let's find out from the first strategy. And this might be, it might take, yeah. So, oh yeah, before we start, this, you could, instead of, if you're like, not interested in using the array, and the standard algorithm is like the most important, like, it's like a new way to solve, but, and yeah, so you could also do this. So you could do the standard algorithm, this, with also this. You don't only, you could also do it with this strategy, this drawing strategy, and you could also do this with this. So if you don't want to do the standard algorithm, for example, then you could just, and you want to do like a problem like 5 times 3, like we just did together, then you could obviously do the array, or this idea, or other ideas that you know. And yeah, so, and this proves, this is 15, this results in 15. And this results in 15, I wrote here. And yeah. So now let's go to the next problem. 3 times 6 equals what? Well, we could use let's use the array first. Array idea. So there's, yeah, you could do it. So there's 3 dots. Oops, there's 3 dots over 6 to the side, 3 down and 6 to the side. 4, 5, 6, 1, 2, 3, 6, one more row, 3, okay, one more. Oops, sorry, okay, there, 6. So for array also, try your best to line it up. So like I did here, try not to make these mistakes here, like there's a bit, like a minor, but since, yeah, this is what I could do best. So now, like, this is 3, 6. So yeah, you could do 3 rows of 6 or 6 rows of 3. This is what it means. Okay, so you could count by 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No, I mean 3 times 6 is what? So, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 9. You could prove that 3 times 3 is 9. And you could split this in half or solve it, but it might be quicker if you maybe do it. Oh yeah, there's maybe 2 ways. I just discovered it. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So as a result, this is 18. So you could first, before we solve this question mark, we should also do the other strategies, other ways to solve it in order to maybe prove it. Okay, so now let's go to this idea, which is called maybe, not exactly sure, but you could search it in Google, and yeah, you could sort of, or yeah, search Google. So this idea is the array. So the spelling is ARRAY, and I said second, I'm not sure, and this yeah. So for this, it's called the standard algorithm. It's 2 words. So the first standard is spelled STARNDARD, and the algorithm is ALGRITHM. Yeah, if I'm incorrect, please tell me in the comment section below. So we're going to use this idea over here, to now. Okay, so let's draw maybe, yeah, 3 circles. And inside those circles are 6 dots. Let me try to draw that. Or you could do it the other way, because like how this is like sort of similar to addition, multiplication, is that it's sort of, you know, so like it's like before you learn something more advanced using addition, subtraction, multiplication, and division in the future, multiplication can add up, go to bigger numbers or smaller numbers, but oops, I did accidentally 9, sorry. And yeah, so but in 3rd grade, you only learn that multiplication factors, and they are bigger than 3 and bigger than 6. And same here, 15 is greater than 3, 15 is greater than 5. So, or 5 is less than 15, 3 is less than 15, obviously. Okay, now we have 6 here. So this is 3 groups. 3 groups. Group. 3 groups of 6. So there's 3 circles with 6 dots inside, and that's called 3 groups of 6. And so also after this problem, we have one more problem, which is one of the important. It's very important also. You must remember that. And the answer is pretty simple. So 3 groups of 6. So technically, let's count the dots in there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this also equals 18. The result for this is 18. So let's use the standard algorithm. And also, since standard, if you can't really understand, you could use the standard algorithm. First, let's write this with this idea, or the array over up here. Oops, it's a bit big. So the result is 18 for this too. You could do it together and you could prove that you could do one of these two and prove that in standard algorithm is 18. So 3 times 6 is question mark, but question mark equals 18. Okay, the last problem, let me delete this, will be here. So what is maybe 0 times 9? Oops, let me rewrite that. Oop. 0 times 9 equals what? Or question mark. So let's solve this. Even many people will know 0 times 9 is 0, but let's prove how 0 times 9 is 0. So first let's use the array. So there's 0, or actually use that, another, the previous, the groups thing. Okay, so there's 0 groups of literally 9. So there's no dots. So first let's write the statement, 0 groups of 9. So for this statement, so there's technically no circles at all, and times 9, there's no groups, then it's sort of like maybe, so it's not like sort of, it's not really look like a familiar, for example, 9 times 2. It's not like a drawing. It's sort of like a not usual drawing. So there's 0 groups of 9, so technically there's no circles, and there's, so, but the reason why 0 times, so for better understanding, the primary reason why 0 times 9 is 9, 0, is, look. So there's no, so technically you could say that there's, for 9 times 1, for example, there's 1 9, which makes it 9. For 9 times 2, it's 18, but there's 2 9s. You could say that it's 9 plus 9 equals 18 also, or 9 times 2. So similar for this, there's no 0 times 9 is that there's no 9s, which makes it, there's like no 9s for times 0. Yeah, times 0. This is also another way to, let me just, for times 0. This is another way to draw 0. So there's no 9s, 4s, and 0. So there's like no 9s, which makes it 0. This applies for every single number that times with 0. For example, the answer is 0 for 0 times, for 0 times 5,000. Answer is 0. So for this, same as 0 times 9, let me redraw that, is like same for 0 times 9. It's the reason why it's 0 is there's no 5,000s. There's 0 5,000. Like there's like if there's 1 times 1, there's you times 5,000 from 1 times many as 5,000, which is 5,000. There's from 5,000 there's 0 times many. So why not 5,000? Well, so technically it's sort of confusing, but there's no 5,000. So you could do, even though you reverse this like this, and 0 comes in the end, still 0. The switching never changes the answer for multiplication. And yeah, so the switching of the position of the number never changes the product, which is technically another way to say answer for multiplication or times. So there's, for this, like 9, so there's no 5,000. There's no 5,000 if you times 0. There's like 0 5,000s, which is obviously 0. How come like it can't be? Yeah, so. And yeah. So this is pretty much it for multiplication. There's also other important parts of multiplication, but this is the one part that I'm gonna teach you today. And I hope you found this video helpful, and bye bye.